Thank you. All right. So I never remember what the title I'm supposed to use, so I changed it. This is a monolith. So nice. Why would you want to crush it? Yeah, problem is, of course, if you're standing down here and the wind starts blowing, which is kind of the situation we're having at Klarna now. So this is the title that my boss wanted me to use for the speech. I thought it was a bit long. It was actually longer than the speech, but anyway, this is what I'm going to talk about. So I was told that I was supposed to introduce myself because John Henry here can't really be trusted. Yeah, that's it. 10 years at Ericsson. I came to Ericsson in 1997. I was working on the AXD 301, the terrible trio we were talking about earlier today. Interesting experience. Now I'm just an architect. So then I have to make these really simple diagrams. So this is Klarna, where I work now. So what's that all about then? It's kind of a mission impossible there. We want to make it fun to pay money to us. It should be safe and simple and fun. Of course, you can also get stuff for your money. That's kind of the drawback there. But anyways, so the business idea is to work together with e-stores, people selling stuff on the internet, and handle their payments, or the payment. So the consumer can buy stuff from the e-store, and then they pay us money, and we pay the e-store, the merchants. And what's in it for them, since we're specialized in taking risks, credit risks, we can do a much better job than the merchants in assessing the risk that the consumer doesn't pay us. And that means we can make it simpler to pay. If you go to the checkout, you don't have to deal with credit card numbers or bank transfers or stuff like that. You can just fill in typically your email address and some address info. And then we'll make sure that you get the stuff, and then when you get your goods, then you pay. This makes people want to buy more stuff. So typically, when we get an e-store on board, they increase their revenue by 20%, which makes it easy for our sales people to get their bonuses. So what does that mean in technical terms? Yeah. So the killer feature is this real-time risk assessment. So what we can do is to make a pretty good guess at how likely it is you pay us money, and we can do that within 3 seconds, and only with stuff, information that you send us normally. So it sounds kind of impressive. Of course, yeah, I'll get to that later. We have a lot of settlement options. That means when you get your goods, you can pay us money in several different ways. We have a pretty big customer care department, so if there's a problem, you can call in to us, and there's a bunch of people that take care of your problem on the phone. We have fraud, anti-fraud measures, both automatic and with people, and we're highly available. Yes. Maybe I should strike out some words there. We have a new product, the Klarna checkout. So in our traditional solution, it's just an API with a wonderful technology, XML-RPC, so that merchants integrate against us with over HTTP, pretty much. Now our new product is that we have a checkout, which is hosted by us. So our checkout page is embedded in the e-store's purchase flow. And since we are good at assessing risk, it makes it much simpler to check out from your basket or whatever it's called. So that puts a lot more stress on our availability and responsiveness, because now we're dealing directly with end customers. Yeah, so I guess I really already went through this bit. So how is this done then? So this is our current architecture. Yeah, I guess it is an architecture. It's so this picture here illustrates our interactions with the world, right? So there's all these bubbles are stuff that we do towards customers, or internal or external customers. We send paper invoices, we send emails, SMSs, we talk to the banks, we talk to the customers, we talk to the stores, we buy credit information from information vendors, the NSA, the CIA, Facebook, and then we have hundreds of customer care agents that also work against our system. So there's all these arrows and stuff, and everything is handled by the big blue blob here, which is called CRED. It's essentially a big, huge Erlang program that runs on two machines, master and slave, and does all of this. And most of it's implemented as transactions in Mnesia. So for example, if you want to use our GUI, the customer care agent wants to use the GUI to fix some problem, we have an Erlang program that generates that HTML and runs it in a Mnesia transaction, essentially. This is has a lot of advantages. It's all the data is always there. It's a pretty simple model to work in, but it also has some drawbacks, of course, and they've been kind of exposed by our incredible success. So this is when I started working at Klarna. So this is purchases per month. So that's every time we buy an invoice from an e-store. This is where I started working. I don't know, I can't even interpolate down to that, but it was like one purchase per minute maybe. Nah, maybe a little bit more than that. So now we're quite a bit more successul. And the peaks you see here is that's annual cycle. So the big peaks are Christmas, or 3 weeks before Christmas. It's when we peak, when people buy Christmas gifts. Yeah. So this is of course a good problem, because our business model means that our revenue is linearly proportional to the number of purchases. So money's flowing in at a high rate, which is good, of course. But what's not so great is that we've increased our volume. So this is the logarithm, 10 logarithm of the previous plot. So you can see that since New Year's 2007, we've increased the volume by about a factor of 100. our system, we've been doing our scaling by buying bigger machines, which is of course great until you already bought the biggest one there is. Then you have to go to plan B. So this is snapshot of the system. This is just like Unix top, but inside the emulator. So you can see here, it says 530 G there. That's how much memory RAM memory we allocated for this emulator. So we have these two machines. They have 2 terabytes of RAM, and they each run one instance of the Erlang VM, and they typically use up about half a terabyte each. They're identical. We have 1,600 Erlang processes, which is not bad. That's mostly web server processes. And ETS, the in-memory database, uses up most of it, 470 gigabytes. So we've run into some interesting bugs. We found a bug in the garbage collector, for example. You couldn't have a single Erlang process that used up more than 32 gigabytes of memory. Apparently, they hadn't tested that at Ericsson. It's pathetic, but yeah. This is an R14, so it's fixed now. There's another interesting point here is that so there's one process here, your server process. So that's a GUI process. That's one of those processes that generate the web page. It's using up 17 gigabytes of memory and 2 cores worth of CPU. So that turned out to be a bug. Somebody who was actually in the room now had written some code that had an infinite loop in it and was not tail recursive. So like 10 seconds after this snapshot, the machine went down. And since we're using 500 gigabytes of memory, it takes over an hour for the system to restart. So failed over to the slave, but we still had some downtime. So that, of course, illustrates the problem here, that we don't have a lot of failure isolation. If some process takes down the emulator, then everything is gone. Yeah, sure. It's we're gone for the time it takes for the failover to happen, which is typically about a minute. In this particular instance, the slave also went down. So, in an unrelated bug, it was totally weird. So the architecture has some drawbacks, and we're of course we've thought about this. It's pretty obvious there if you break the system down and all the functionality down into domains like this. The one at the top there, the soft-realtime one, is different from the others in the sense that that's the thing that has to be very available and very responsive, and the other ones we can do, except for the GUIs, we can do it in batch. So the phenomenal idea here, the brilliant insight was that we could separate the system in the front and the back end. And also to decouple the database from the business logic. So it's very intimately tied to our system. The functioning of the system is very intimately tied to Amnesia and how that works. For example, the master-slave replication is done by hooking in under the hood on Amnesia. Yeah. So to get horizontal scaling, we needed to decouple. We also had problems with, or have problems with the productivity of the developers. And the system is pretty complicated now, and everything is connected to everything else. It takes a very long time for the developers to to get up to speed in working with the system, the CRED. It doesn't typically take very long for them to learn Erlang, but normally it takes about 2 years until they're really self-going, self-propelled. They have the skills to actually do serious work in the system. Yeah, it's also a good word to use if you're talking to management. Decoupling, hey, fancy. All right, so this is what our backend is going to be. So yeah, so Fred and Bender are like little humorous words. Fred is the front end and Bender is the back end. So this is what Bender is going to look like. So the front end top there is outside the system, Fred, and it's connected to the back end front end connections through message queues. Then that goes into another broker, and then we store everything in Hadoop, and we have a bunch of services that run on top of the message broker. And that's this slide. It's the services. So the interesting thing about this, one observation you can make there is that most of this stuff is nothing special for Klarna, right? Everybody needs a GUI, bookkeeping, blah, blah, blah. The dunning is a bit special for us. For those who don't know, that's when you, so each time we take and purchase from an e-store, we basically start a timer, and after so and so many days, we're supposed to send out a reminder or an invoice, or send them to the, I don't know, send for the guys with the lead pipes to go collect our money and stuff like that. It's called kravkedja in Swedish. That's a bit special for us, but most of this we can buy products from Microsoft or IBM. Of course, originally when the system was created, they didn't have any money. They couldn't pay $1 million to Microsoft for a business intelligence system. So, whoop. All right, Fred is the front-end service. It's soft-realtime. So we have contractual obligations with some of our merchants to, if we don't answer within 3-5 seconds, something like that, means we take the risk for this purchase. So it's important that we actually answer something sensible. Otherwise, we're stuck with that piece of business. So it needs to be responsive and available. We also wanted to port most of the purchase logic from CRED, our old system, because the migration here is kind of tricky. That we can't just take the system down and start up the new one 3 weeks later. It has to be the migration has to happen in operation, and we want to be able to switch back and forth and run purchases through both systems, stuff like that. So also we didn't want to lose all the knowledge that's in the old code. So the scope here for Fred is, so I was talking about the API we have against the merchants. We want to handle some of the API methods there, but not all of them. Only the ones that actually create purchases. We wanted to host our checkout there, the ID service and risk service. And the risk service is broken up into pieces here. So the 3 stages of the risk assessment that can handle different kinds of failure scenarios. So Fred has knockout units. It's a great word. I learned at Ericsson. So there's 4 levels of knockout units. So we have Fred clusters on several data centers. A cluster has a number of machines, 5 to 10. And each machine runs the same code as all of them. There's no master. They're all identical code-wise and function-wise. And the business logic is broken up into these services. And that's partly so that a service can fail and we still reply, but also so that the teams are not so tightly coupled, or the function of the teams. The teams can function more individually and don't have to take all the other code into account when they do a change. So this is what that looks like. I had my 5-year-old draw this picture with little boxes and stuff. It's
Your 5-year-old is 10-year-old.
Yes, that was 5 years ago. It looks like it's made by crayons, but it's actually a highly professional graphical designer who's done this. So there's a load balancer. This is one Fred machine. It has a database abstraction layer and a service orchestrator, which is an engine that calls these services in a special order and passes a context between them. So this thing also terminates the HTTP and make sure that we answer in timely fashion, even if some of the services go down. The SSL is terminated in the load balancer. Some of our stores actually send all their traffic over HTTP, which is annoying. Yeah. Okay. Yes. So it's based on React. It's a distributed key value store, and so each of these Fred machines have are running a React instance, and each Fred cluster is a ring, React ring, as of now. This is our tech stack for Fred. We've been through various Linux variants. When I started Klarna, we had Gen 2, I think. Then we went to Debian. Now it's Red Hat. I don't know. Next flavor is going to be same thing, though. We use the web machine, MokiWeb, and React from Basho. RabbitMQ, Erlang, of course, Git, Chef, Rebar, blah, blah, blah. It's pretty heavily tilted towards open source software. We pay for some of this, but most of it is from GitHub. The Red Hat, we were pretty happy with Debian, but because of our memory requirements, we bought some fancy hardware that was certified for Red Hat only, so we had to go to Red Hat for that reason. So React is the basis of Fred. So why is that? Is that because we're hipsters? Clearly not. I'm standing here looking incredibly unhip. We wanted a distributed database, and the use case is such that we didn't need transactions in Fred. So distributed key value store sounded good. The React guys put a lot of effort into making it easy to run the database. It has all kinds of metrics and dashboards and stuff. That's nice. They're good coders, and they have something called React Search, which is something based on Lucene that we wanted to use for our identification engine. In the old system, we build our own indexes for address matching and stuff like that, and some limiting. It's kind of hard to get it right. It's easier to use. Well, we wanted to have the ability to use leucine, anyways. So this was 2 years ago when we drew this up, and there wasn't really any good competition. We were looking at Cassandra. It wasn't very stable back then. And the data center application is interesting. We don't use that, but now, but we probably will in the future. So the drawback with React is a drawback. It's a feature of React that you can create siblings. So if there's some sort of split, just because we have a network split, we can't stop the system, of course. We have to be available anyways, so we can create siblings, and that means we have to be able to resolve those. There's some strategies there. You can merge them. If you have two a sibling of an object, that only difference is that they have some list of goods, for example. It might be sensible just to merge those lists, do a unique sort on them, something. You can just pick one, or the original idea with Fred was that the use case was such that we would never get siblings. So we would create an order and never mutate it, and we would make sure that the keys were unique. So that's pretty much holding up. So that's actually worked out fine. But yeah, I'll get to it later. The big problem here with this whole deployment of this new architecture is not to actually to create the system. Well, that's of course non-trivial task, but what's really complicating it is that we have all these existing merchants. So that's where all the money is coming from. 15,000 in seven different countries. And the API is pretty old now. I think the first one was from 2005. There's, I don't know how many versions of it that we're still supporting. We never deprecated any of them, I think. So it's like 30 versions of the API. 10 of them or so that are pretty still used. And there's a lot of quirks and strange legacy stuff in the code that some of the merchants rely on. And we don't really know who's using what. It's hard to see. So, and that's, of course, one of the reasons why we backported most of the business logic here. We don't really understand everything it does. So this is what our migration looks like. So we have the Fred, the new system, Fred. And so we terminate all the API requests on Fred. We look at it, we unpack it, look at it. In case it's something that we handle in the Fred, then we handle it and reply. Otherwise, we just proxy it back to CRED. So CRED has all the functionality already, of course. And then we flip in more and more functionality like this, and every time eventually we're going to have all the stuff here in Fred, and we can get rid of these bits of CRED. So this is the RPC API. So it's still going to do all the back-end stuff for the time being. So this is where we are now. So the Freds are live. They're taking one of the API calls, proxying everything else. So by this fall, we're going to roll out the rest of it. And the checkout as well, which is not on this slide. So I thought I'd say something about the resistance to change. When we do a big, huge transformation like this, well, I had fear that people would be a lot of internal strife. But Not really. There was some not invented here. So we're doing more. We're not building everything ourselves from scratch anymore. And so there's been some, I don't know, not conflicts, but some arguing about pulling in more external components. But that's not really been a problem, though. But what has been a problem is this new model of programming, that you can't assume that all the data is always there. You can just look in Amnesia and find out what the hell. If you need some data, you just do a dirty read. Also doesn't work anymore. The spaghetti is. There's been I don't know how many. Several hundred people have committed code to this code base. Not all of them have been excellent programmers, and but most of them, of course, virtually all of them. But not all of them has really understood how the system works. So there's a lot of strange stuff there. There's been a lot of infrastructure work for getting all the logging and basic stuff like that. Compatibility with the old behaviors and old bugs. In some cases, we have to be backwards bug compatible. Pain in the ass. And of course, we don't have any specs. There's been some obstacles there, but in conclusion, I start from end with my title here. We're actually almost deployed this now. So, yay. Thank you for listening.
And we have plenty of time for questions.
So I want to ask about the backend. So what's the backend here? There some early slide where you mentioned Hadoop.
Yeah.
So is that all commercial stuff you bought?
Right now it's CRED, right? So we're implementing Hadoop. We're going to use that as a data vault and then blow out.
So CRED is vendor.
Yeah, now it's being phased out, right? So right now CRED is vendor, yes, exactly. But we're going to hook up CRED to this infrastructure as one of the services there, and then move more and more functionality out of CRED.
So what is this infrastructure? What's the message broker?
This is something called CAML. So it's a message bus, enterprise service bus.
So this is all stuff you buy from?
CAML is open source. It's Apache. Hadoop is free, of course, and we're also using Postgres as so we materialize views from Hadoop up in our will into the services. But the bookkeeping system, for example, is from Microsoft. The business intelligence system is from IBM.
What is that?
Business intelligence.
Yeah.
Well, then when you take data from your data vault and turn it into a form that business analysts can use. I can't explain that any better. I don't understand it myself. But for example, if we hypothetically start business in a new country, there's like literally 100 people that want to figure out exactly how it's going and what segments of the business is doing the best, and I don't know. So they have traditionally with in the olden days we just write every time they needed some information. We write a report, which is an Erlang program that worked in Amnesia and generated a CSV file that we mailed to these people, and they could read it into Excel. So they were unhappy with this way of working. So now we're exporting, we're hooking into the Amnesia replication, KDB replication, and exporting large subset of the data into Postgres machines. And so the business intelligence people work against that. No kidding, 100 people. I don't know if I answered your question.
Sure.
All right, thank you.
Looking at this thing, it looks a bit like calls or CQRS, command query responsibility separation. Is that what you're doing, or is it something similar?
I don't know what that is, but it sounds good. So that's what we're doing. Hell yes.
Perhaps you reinvented it then.
Yes. I think I've noticed that every time I come up with a good idea, it was already invented by some German guy 100 years ago. So, and if it's not already invented, it's probably a bad idea. We haven't made so much progress in the back end yet. And I mean, this is what we're building. We have an instance of Hadoop. It's not getting all the data yet. We're working on hooking up CRED to this message broker, which is in place. We have one service that's live, and that's the PDF generation that you guys might know about. So as an anecdote, I can say that we send out like, I think it's like 10 million pieces of paper per month. Yeah, something like that. It's millions and millions of pieces of paper we mail out, invoices and reminders and stuff like that. And many of them have little machine-readable forms on them. And up until a year ago, every single one of those documents were generated by an Erlang program. So there was, for each document type, we had an Erlang program that would draw little lines in a PDF document, which made it a 2-week task to move a line 5 millimeters to the left, or move the logo to the right instead of the left. Yeah. Also, our graphical designers were not super happy with this solution. They had to do everything in Photoshop or something, and then print it out and then give it to a programmer, and he would sit with a ruler and figure out how many millimeters I should move the pen. But now we have a real system. Where the designers can work in a GUI to make the graphical stuff. It's brilliant. It's actually using Erlang. It worked really fine, except for the fact that you needed to be have a PhD in Erlang programming to design a document. And yeah, sure. If you can look at a 5,000-page 5,000-line Erlang program and figure out exactly which line of code moved which line on the paper. Yeah. It's easy in principle. Yes, we didn't think of that. Yes.
So you're pulling more, it sounded like you're pulling more and more external components into the system, like IBM thingy and...
Yeah.
And so how does it go? Are you doing this only for offline? I mean, it's really quite impressive. You can't do that actually, but how does that go with integrating that stuff? Is it worth it?
I think the experience is that if we can buy something that does exactly what we want, then that's great. Then we can integrate against it. If we have to go into this, if we buy something from Microsoft saying we have to customize it, then it's a problem. But I mean, for the bookkeeping system, for example, Microsoft has 800 people working on it, and it's 10 years old, so it's 8,000 man-years or something. And most of it is exactly what we want. So there's no way we can re-implement that better. So depends, I guess. But for the front-end stuff, which is pretty much more unusual thing, we need to be able to customize it a lot, and there's not a lot of people that does exactly this, so then it doesn't make sense to try to buy something. But for example, printing PDF, generating PDF documents from templates is not something that we need to be world class or even particularly good at. And we can buy something that does that well. Makes a lot of sense.
It looks like you're going from a monolith to, like, you're having a sort of broken up thing in the back end, but the front end is still, you're aiming for another monolith there. Like you're trying to collect everything into that green box that wasn't left.
So the business logic is all in those green bubbles there, sources. So that's like the risk assessment, the ID matching stuff, the actual business logic of making a purchase, specifying payment options and stuff like that. And so each one of those, most of the code here is in the green bubbles. All the business logic is there, except for the actual flows where you define which order you're going to call this and stuff like that, depending.
Arbitrary many thread machines in a cluster, right?
Yes. That's right. So logically, the thread machines are all identical. That's we wanted to get away from the master-slave failover scenario. So any one of them can take a purchase. It's maybe the second system syndrome in action there, but I think that makes scaling a lot easier if they're identical. We can just slot in more machines.
What do you store in the React? Is that like just used as a cache?
Essentially, yes. So we store once we've accepted the purchase, we make something called an order blob, which is a bunch of data that describes that purchase. And that's cached in React, and now it's moved to the backend over the message queue. But if the backend is down, we store it there. And then we also store enough information to run this risk and ID assessment stuff. But all of that is also available in the backend or the other React machines. So we don't have to restore anything to.
Do you fetch the risk assessment data for each new purchase, or do you have that already readily available in React?
It's pushed up from the backend. If, for example, if somebody pays a bill, a customer pays a bill, and we push some information up to all the threads. So even if the threads get disconnected from the backend, they keep working.
One more question before we head off lunch.
I have two questions. One is
Facepalm.
related somehow. First one is, from your experience, what would be the pros and cons of React and Fusion? And the second question is, would you consider moving from Hadoop to React to do business intelligence stuff?
The second question, yes, I can certainly see that. So Hadoop is more like you just push stuff in there and then you can materialize views, but it's pretty slow. I could see that we could use React as well, or instead maybe. It depends on. I think React is more useful as a sort of caching style operation. Not as to archive many terabytes, although it might work with that too. I forgot the first question.
The first question is, in more or less, which deployments or setups would you prefer React over Misha?
I think Misha is great if you have a system. Maybe if the task is such that you need 1 or 2 machines, the distribution is not great on Misha. Some people say it's not even usable and write their own layer on top of it. But so if the use case is such that you have 1 machine or a few machines and you don't need to do very fast replication and you want transactions, and Misha is actually great, and I've shown this. Yeah, we always piss and moan about the system, of course, but and how sucky it is. But if you look at this, this is here. Essentially it's exactly the same thing as Clucky and those guys wrote back in 2005. It's freaking amazing that it still works. Well, and we've done a lot of tweaks and stuff on it, but it's still fundamentally running Amnesia, and it's pretty awesome. But it's not going to scale up to a multi-data center kind of environment, and then there's no way you can. I mean, sure, you could probably reinvent something, some sort of distribution layer on top of it. It was really great, but why? You know, there's especially in our use case where we don't, for the order creations, we don't need transactions. And so, I don't know, I was just babbling there. I didn't really answer the question.
Is that in the initial ideas around the systems that we were envisioning 3 million purchases? Not on and off.
No, that's it's amazing. Yeah, it really is. And it's always, every year since I started down here, we thought that, wow, this is going to be really tough this Christmas. And then we bought bigger machines, we've optimized and tweaked the system, and it could probably go on for a little bit longer. But it's actually getting more and more difficult to. The business is growing faster than we can make the system slicker. So, sorry.
Right.
Shouldn't keep you from lunch.
Don't forget to vote as you leave the room. The colour to remember is green, right?
Thank you, Johan.